we don't know, so we have to investigate. So this is part of the engineer oversight. He will not let a building get load tested unless he does some investigation to verify the connection. So sometimes when these connections are through the building and there's a plate, it's an easy verification. You don't have to go through this silly activity. But every now and then you don't have this available to you, and what you have to do is you have to do some verification. Now this is another part that we talked about, and that is how small some of these fire escapes are and some of the missing pieces. Now, when you have very small balconies, missing railings, we have to talk to you about those and what could happen when, you know, that's me right there in the middle trying to get through a fire escape that barely has enough for my belly to get through. What about if I had full tanks, full everything? How are you going to get through these fire escapes? This is that case that we were involved in New York, and the fireman fell through 2 or 3 treads right there. 2 years later, as part of an investigation that brought us in to check the fire escape, guess what's the only thing that was certifiable? Those 2 or 3 treads. Guess what was not? What was not certifiable was the rest of the fire escape. So my foot came through, and as we started walking up, pieces were falling. So we just started videotaping. We were videotaping anyway and recording. Now, I'm about to tell you, and you can use this as examples. If you go to page, this page right here. We're gonna get into this next, and this is how all fire escapes in the United States are built. If they're attached to a masonry wall or they're attached to a wood structure. So I'm gonna start telling you where rust comes from, and it's this part of the class that's very important because then we're gonna go right into these, how fire escapes are built. And since you know where rust is going to come from, whether it comes from the outside in or from the inside out. So, is there such a thing as a fire escape depot that you can go buy treads, components, and was there one 75 years ago? There was. There used to be hundreds of fire escape companies 75 years ago. How do you think Chicago got built, New York got built, everybody? There was just hundreds and hundreds of these fire escape companies. Mass producing. Then some crazy guy, I don't know if he was a fireman or a building inspector, says, you know what, in 1930, says, you know what, these fire escapes on the outside was the craziest thing we've ever done. No more fire escapes. In 1930. What happened to those hundreds and hundreds of fire escape companies that were putting these things out? They went out of business. They went into something else. Every single one. How many fire escape companies is there today that just do fire escapes? None. Oh, I'm sorry, there's one. We do fire escapes. The only other people that do fire escapes is Joe Welder and ironwork guys. They do railings, window guards, and occasionally they trip over a fire escape. When's the last time you guys saw a brand new fire escape being built? Or they just keep patching these things up forever and ever. So in 1930, when they stopped building fire escapes, was there any maintenance on those fire escapes that were not even 30 years old? That they were building since the 1900s? So, all the companies went out of business and changed business. There was no work to maintain them because they built them well. But let me tell you how fire escapes are built today, if you have to build a brand new one, and how it was built 30 years ago. The steel that you got, and I'm going to use a tread as an example. I got a piece of tread, either riveted or bolted with a square head bolt. Don't forget, every fire escape out there, you want to know its age? If it has a square head bolt or has a rivet, how old is it? 50 to 75 or older. If it has hex head bolts on it, how old is it? 25 to 50. So how easy is it going to be now to see if fire escape has original hardware or it has new hardware? It's just a bolt. Isn't it that simple? You walk up to a fire escape, you look at it, and you say, if it's an old fire escape and it has hex head bolts on it, what has that owner done to it in the past 50 to 75 years? He's refurbished it. If he has nothing but original hardware, you can't see one bolt. What has he done in the past 50 to 75 years? He's painted it. Isn't that what holds fire escapes together? Paint. Right? So he's painted it for you. So you got all these landmines all over your city. So now, if I'm building a fire escape today, like I was 75 years ago, I take a 20-foot piece of steel and I cut it into components to make angles, brackets, railings, but I'm going to build a tread. So So I take these 20-foot pieces of steel, and I need some angle, and I need some flat bar. And when I get these two pieces together, I have to drill a hole in them, and I'm either going to rivet them together or bolt them together back 75 years ago, or I'm going to weld them together today. Do you think I take this naked piece of steel, do you think I prime them before I put them all together? Or do I just take naked steel, drill, weld, and bolt them together right there? Two pieces of steel need what to start the process of rusting? Air and water. Do you guys ever see steel, or like when you've done plumbing on a copper pipe and you start sweating it, and all of a sudden you see the copper like literally lose moisture out of the pipe? Steel gets the same way. Steel sweats. It actually gets moisture in it every day, in and out. So what do you do to stop moisture from getting into a piece of steel? You paint it. So as soon as you build these steel, you try not to build it outside, because what happens if you're building treads and railings outside and it starts raining and there's just general every day-to-day moisture? Do steel companies keep all their steel outside, their naked steel outside, or they keep it inside? What happens to all the outside steel that mills keep outside? How do you buy it? What color do you buy it in? Brown. If you buy the steel inside, what color is it?
Black.
Black steel. It's just gray or black steel. So when we put a tread together, never painted in between. The first thing you got to do after you build this tread is you got to paint it so that it stops the process of oxidization, which is what rust is. Rust is just steel's way of saying, hey dude, you got paint for me, or can I start oxidizing and rusting, because rusting is my protection. Copper has what does it do in order to protect itself? What's copper's rusting? Patina. You know when the Statue of Liberty is all green? Patina is its form of rust. Otherwise, you go there and scrape the patina off, what happens to the copper? It needs to give copper again to turn it into green to protect itself from the weather. So rust is what iron does to protect itself if you're not going to paint it. But as it gives of itself year after year after year, what happens to the metal? So that's why you paint steel. So now I've got these two pieces of steel. This thing is 5 years old. What do you get right away in the first 5 years? You get a little bit of rust. It's called surface rust. Surface rust means when you get two pieces of steel and air and water is trying to get in, where's it get in? From the top or from the bottom? Top. And once it get in, because that's the easiest. When it rains, it just sits there and pools for a little while, and then it gets in there. So it'll start trying to penetrate the connection and do this. It'll actually open up the top, because rust is called rust jacking. You guys know what the power of ice can do, right? You put water inside anything, what's it do? When it ices, it'll split anything, right? What do you think rust does to anything? Cement or steel? If you let rust grow, what do you think it does? It'll start jacking it. It'll start doing that. Now, has it penetrated all the way through? That's just surface rust. So you leave surface rust, it's just the top. You wire brush it, and then you paint it. You have to kill it exactly where it is, because what happens is you stopped letting it rust. You have to stop the rusting process, and it needs encapsulation. It needs to be painted, maintained. That's why they have the rule: must be maintained, must be structurally sound. It's not must be structurally sound, and whenever you can paint it, it must be kept painted so that it stays structurally sound. So you should write that down. Must be kept painted so that it stays structurally sound. Otherwise, if you have not been painting it, you are now deputized structural engineers, because every engineer will back you up and say, yes, if you don't maintain it, it will get structurally unsound. It's a structural engineer's statement. You've let the connection be penetrated by the worst thing you can ever have in a connection, which I won't sign off on, water and air. So I clean that and I repaint it. Is that what happens? Is that what happens 5 years after you put up a brand new fire escape? Does the owner go there and scrape the fire escape and paint it? Or does he leave it alone? Leaves it alone. Then it goes into the second 5, 10, 15 years. And what happens to that connection that started like this, and the jacking was able to get through it? And I can visually now see 1/8, 1/4 inch of rust down the whole clip. That entire connection just did this, 1/4 inch, 1/8 or 1/4. So what it was just surface rust up here before now is 1/4 inch separation. What did I do to that bolt or that rivet that was in there? Did it let go a little bit? Anybody ever see rivets? Do rivets have any nuts on the back? Or is it just smashed? Smash. So this thing just moved a quarter of an inch. So it stretches your rivets or your bolts. And were they made to stretch? Any bolt or rivet that's been stretched, is it compromised or is it still sound? Compromised. So this is a visual inspection. The rust has done this. And all of a sudden now, the only thing keeping you from falling down in that tread is that the rivet is still blocking the ability of this angle from dropping. So what's holding you? Is it the rivet or the fact that the rivet is a peg? It's a pin that's in your way. All right? So you're stepping on this rusty connection and it's still holding you and you think, wow, these things hold forever. When in actuality, it's just a block. It's a bump. It's a bump in the road that this thing can't get through yet. So then, you think the guy fixes it now? Or does he bring out a welder and welds the nose of the tread? Does he stop the rust and remove 100% of the rust, which is the original violation? Did they do that? Well, there's no engineer oversight. What did the vendor do? Is he going to get 20 grand to refurbish this fire escape or 2 grand to... And 2 grand get you what? A welding job and a paint job? So if a tread fix that tread, what about the other ones? It's not my problem. I only got paid to fix this one tread and paint the rest of the thing, right? Make it look good. Now I've got 1/4 to 1/2 inch of rust. Now that peg that used to stop my clip from dropping, you remember that hammer test? Now, when you guys come down the fire or go up the fire escape and you step on a clip that has rust of a 1/4 inch or 1/2 inch and it's either eaten the entire rivet or the bolt and there's nothing there to impede the angle from just passing through, now that's when you get hurt. That takes 50 to 75 years worth of neglect. This is when you step on it. This is how much rust was on this fire escape that the fireman, 2 years later, that's how much rust was on there. And as we're walking up this thing, my own weight is starting to drop the treads. This is tenants and this is firemen. One of the laws we think we should enact in the nation that will get the attention of the landlords is that all rent checks should be collected now through the fire escapes. And all people should put their rent on the outside of their window and then notify their landlord to come up the fire escape and get their rent check. Now that'll be monthly testing, and every now and then you will hear about a dead landlord. And the estate will immediately fix the fire escape right after the funeral. Since that law doesn't seem to be coming anytime soon, we need to get on this, we need to have several tricks of how we're going to stay on top of these fire escapes. So don't forget, code official, he has to add it to his permit process. Anybody pulls any permit in the building, they can't close that permit until they have a current certificate on file. So they're not asking for inspections, they're asking for a current certification. On your side, when you guys do the smoke detector sign-offs, which allows the occupancy, what do you ask? Because if there's smoke in the building, what 2 options do I have? The internal stair and the second means of egress, and if it's an exterior steel or wooden egress, which sometimes is called a fire escape, I need maintenance records on it and or certification and load tests. And if they go, I don't have it, so 50% of the egress now is compromised. So the smoke detector is going off, but how many places can I go? So can you stop the smoke detector sign-off? A lot of cities says you can't stop, but you already have the knowledge now, right? That they don't have a certificate on there, so that's just another violation, right? So you can proceed, you can impede, you can do whatever you want. Whether or not you're going to allow them to occupy that building with a fire escape that's not been tested is your choice. But now you know, because you asked for it. Make it a checklist on your smoke detectors. Where's the certification on your fire escape? Okay? These are just suggestions that they're using nationwide. All right, now let's start looking at this. 100% of all the fire escapes in the United States are not going to be covered by these little things. So you can draw and circle and let's talk about, again, masonry buildings. They go 8 to 12 inches deep into the wall. They do not just hang on the veneer. They go into the building 8 to 12 inches and it's just a pocket of cement. And if water gets in here between the gap, it'll rot this out, which we've shown you, correct? When water gets in there and freeze and thaw occurs and rust jacking occurs, or ice jacking they call it occurs, if that happens, it snaps bricks, snaps sills, and that's an indicator that you got problems. Cement just doesn't blow out like that. It needs something behind it pushing it out. Sometimes people forget, see this one piece of steel is holding up 2 full staircases. You think it can do that, or you think it's missing its brace? Did somebody remove the brace and not put it back? Because if this thing's only buried 8 to 12 inches deep into the wall and you got 2 staircases on it, you think it's going to hold when you put a bunch of firemen on there? So sometimes people take away things, they never put it back. So this is what a brace looks like. Now, a lot of your brackets have a single bolt or they have a bracket, it's called a gusset. Those all must be in good condition. Otherwise, can you hold 1,800 pounds on a load test if these brackets are gone? A lot of times the lower brace is throwing water into the building also. So a lot of times we fill this up with tar so that the water falls out way before it gets near the building. Sometimes in masonry buildings, very rare, they're not pocketed into the buildings. There is actually a full through bolt all the way through, and somewhere on the inside masonry wall, there's a plate or some of these buttons. And there's a lot of force on that. Guess what it does to the brick? So I need to verify on the inside. And if these are unverifiable, I have to fix them before I can load test them outside. Or I can just leave this alone and just put new epoxy bolts into the building. I got time, because some of these are behind sheetrock. They're not exposed the way they are right here. So as you can see, it'll start smashing through bricks on the inside. So this is a through bolt on a masonry building. Very rare. Less than 5% of the buildings that are masonry are through bolted. A lot of them are just pocketed into 8 to 12 inches deep. In case you're looking to grow moss or ferns, or you know how much water you need to constantly throw on a wall to get it to grow? Mold to make it grow moss and ferns. In case you want to learn how to grow ferns, fire escapes are great for ferns. This is a parking garage. This is a library. How long does it take to grow 1 inch of rust on a gusset, holding in the entire platform up in the air? This is a city library. In case you want to grow some more ferns again. There's a lot of water and dirt to grow. Now, another way that fire escapes are is that they're not only pocketed into the building, but there's also a lake to the ground. So the building is a lake, there's a lake here, so this is basically a small bridge between. So not all fire escapes are connected into the building, they sometimes have lakes to the ground. Like this one. Lakes to the ground. Sometimes trucks smash into these things, and that is just the veneer that cracked. When we opened this up, where it was tied into the masonry on the inside, it was still good. But the veneer was cracked. It looked worse than it really was. Yes, question?
Do you do a load test and just fix whatever fails? I mean, is that a normal procedure to
No.
do a load test and just fix whatever fails?
No, because we know what a pass looks like, but you know what a fail looks like? A fail is catastrophic, and it'll hurt one of the testers. So a fire escape must pass a confidence test. One that is, anything that's a compromised connection gets fixed immediately. Anything that's based on age. So if I have a 50 to 75-year-old connection, I still won't load test it unless you allow me to reinforce it with a backup bolt, or if it's faster and cheaper to the client, if I can blow those bolts out or those rivets out and put in new ones, then I'll load test it. Now I have a guaranteed load test. But then I'm going to try to convince you that the client just spent 30 grand fixing this fire escape. Why do you want another 10 grand in load test fees when everything we've done is possible? We've verified all the connections into the wall. We've reinforced every bolt that's aged. We've replaced every bolt that was compromised. Why do you want to load test? Why do you want to charge another 10 grand to this client? I'm willing to give you a document that says the fire escape is certified, and in lieu of a load test, and no disclaimers on my document that says, because anything happens to that fire escape 3 years from now, and they try to sue me, and it's got all brand new bolts, who do they really have to sue? Me or the bolt company? It's the bolt company. They picked up all the liability, because if there's gonna be a failure, it's gonna be a bolt, and I didn't make that bolt, somebody manufactured that bolt that failed. So, and this is wood structures. All wood structures must have a backing plate. That basically is picking up some studs on the inside. A lot of times, see this lag screw? Sometimes you're gonna go to a wood structure, and I got 4, 6 of these up and down. Anybody knows that when you have water and air and a lag screw, every day the air and the water gets whipped through your lag screw to the wood. And over 50 to 75 years, guess what happens to the wood around the lag screw? It rots, and guess what happens to the structure that you're going to step on? Pulls away and falls to the ground. So no structure in the United States made of wood has a fire escape lag screwed to it. They all must have, by law, this through bolt, they call it. And that backing plate is on the inside. It picks up the entire wall. So in order for that fire escape to fall, it has to bring what with it? The wall. So keep an eye out for that. So any wood structure with lag screws is illegal as a means of attachment. Cantilevers. This is what a release arm looks like. See what it is? And it's single action requiring no special knowledge. It actually blocks my way. I don't even have to know how to use it. It's in my way. I'm running down this fire escape. It's in my way. What do I do to it? I just push it. And as soon as I push it away, it rotates because only a little piece of it is down, holding the fire escape from coming up. And as soon as I rotate away, guess what starts its active? So as soon as I rotate here, and the woman and the 50-pound child, by the time they reach the pivot point, what happens to the cantilever? It's already hit the ground, bounced a couple of times, and it's doing what? Resting on the ground. She self-evacuates with the child. 1 minute, 10 minutes, 1 hour later, guess who shows up at the dance? You guys do. Guess what you guys use to get on the fire escape? Because it has a nice white tag on it. Guess what you guys don't use? Even though she got off safely, it's got a yellow tag or a red tag. But now you're not trying to evacuate any tenants. Now you surround and drown. Isn't that one of the sayings you guys have? If it's not safe, surround and drown. So this is what happens when you have cantilevers that are not balanced correctly. We have a few of these. Here's a cantilever, ready? With a release arm. Well, the release arm basically traps the weight box. Can you pull it down now? Can you push it up? Do you see the chain? Is the chain nice and tight? Indicating what? That even though the guy released we released the cantilever, what's it doing? It's out of balance. Because if it was properly balanced and it had a chain, that chain sometimes is allowed to have it. Because when I throw it up, because it only weighs 25 pounds on the nose, it's supposed to have a gentleman up above, somebody down below. When you have it on the ground, to put it back into position, somebody below just throws it up. It weighs 25 pounds. You just seesaws. You throw it back up, and the guy upstairs just locks it into position. Okay? As soon as he locks it into position, he then goes back in through the window or through the door, and the thing is ready for use again. But sometimes when you throw it up, if you throw it beyond the horizontal, the chain just stops it from going up too high. But as soon as it comes back down and gets locked into a position, the chain then becomes loose. It just hangs there. So sometimes chains are used for nothing more than to stop it from going beyond the horizontal. But when it's ready to go, it's not tight. Now it's a loose chain because you can see that it wants to start dropping, and the only thing stopping it from dropping is the release arm. Okay? You also have these cantilevers that are all just messes. See all the added weight that the guy put on there just to make this thing stay up? No release arm. These happen all the time. People will modify fire escapes so that the release arm is in the eye. This is what trash trucks do to fire escapes. They smash them silly. Trash trucks. Staircases. There's clips at the top that hold the staircase. There's clips at the bottom that hold the staircase from falling. make sure the top and the bottom, not just the treads are safe, the whole staircase is safe. Otherwise, you have clips at the top that are full of rust. So how safe is your tread if the staircase is ready to fall? Who cares about the tread now, right? You got a full staircase ready to drop. How about this at a major hotel with 25 stories? That's the top of the stair. Already pulled away. The only thing holding that stair in place is the fact that the railing is still tied into it. So the only thing holding an entire staircase for your team to go up is a piece of rail, one little connection on a rail. If that gives. So a lot of these are very evident when you start looking at fire escape. How about this much rust? How many years here? Less than 25 or 25 to 50? How about this? When the steel starts eating, when the tread starts eating the steel, how many years of rust? How about this? How many inspections did this building go through that the inspector never saw this smashed staircase in the back of the building? Now, do you even have to go to the back of the building when you are doing your test? You know, any yearly plans or inspections that you're doing, the smokes or the batteries or the exit signs and stuff, can you have it on your list that you ask for the current certification? Can you add that to your list? A certification or maintenance records of the building on your fire escape egress? Because when you walk on the inside, aren't you checking the inside stair? Do you need to go to the back stair, or can he just provide you with the maintenance records of the back stairs? And if he doesn't have the maintenance records for the back stairs, is this what could be back there that you never checked? So sometimes by asking for the maintenance records and or any load test or certification information on the second means of egress will trigger a violation. Rails, some of them are tied into the building, some of them are screwed into the building. A lot of them just right into the veneer. Rails, where they meet other steel, they accumulate tons of garbage. That's where the rusting starts. Leaves, dirt, pigeon poo. So a lot of these areas will trap. Some of these will have flat bar or they'll have a grating. And these are the spacers that hold the grating at 1 inch apart. You think those rot out? You think anybody paints the inside of those little spacers? Is there any way to fix that? Your foot, if those break, your foot falls through, now you're jammed, you can't pull your foot up. You or children or anybody evacuate the building. Treads. Now these were built wrong because fire escapes have this little angle clip that accumulated dirt. Today's is a piece of flat, 2.5 inches long, and the 1 inch angle grating is actually welded to the top now. So all you have is a 1/4 inch to sit. Otherwise, this is what happens. It starts accumulating rust, these treads fall, and that's where you get hurt. This is an elementary school. Not only can it not, you know that there's a requirement that you may want to write this down, that most elementary schools do not have fire escapes anymore. What about charter schools? Do they use standard schools as their schools? Or do they use renovated office buildings and renovated, and they're supposed to do in a fire, what do you call it? Alarm, not alarm, fire, fire drills. 2 a month, right? One announced, one unannounced. The law says you must walk the kids through the fire escape. Do you know that any of these fire escapes on a building that's used by a charter school that has ladders, can kids come down ladders? So there's some buildings out there that charter schools are using that have ladders on them, and it's illegal. It must be full staircases to the ground. So keep an eye on that. Because the children are supposed to go out on these fire escapes all the time as part of their routine twice a month. Have you ever seen kids egressing on a fire drill out the fire escape? They always force them down the main stair. But they're supposed to be using the fire escape. So charter schools, because some city schools might be old enough to have a fire escape in the back, you got to make sure that this doesn't happen. This was an elementary school. How many years of neglect here to grow 1 inch? Ladders. Ladders are just like cantilevers. They must drop 2 to 3 feet to the ground, operate smoothly, hit the ground and stay down with weights. Otherwise, if you just let a ladder go on these tracks to the ground, what do you really have? It's a guillotine. If you were underneath it and it got dropped by mistake and you were a child or a dog or a person, other than a fireman, could it hurt or kill you? You just guillotine a ladder down. If it doesn't have some way of slowing it down 2 to 3 feet per second, if you release it, it cannot injure anyone. So there's various types of ladders out there. There's these that look like they belong on your attic, but these are the fire escape that basically 4 of them together, they make a long ladder. There's one. Anybody ever see this? It's called the scissor ladder. Used quite often in California and up all the way up to Seattle. And you basically release that and it makes a full ladder, up to 25 feet. So it's acceptable. Fixed ladders, you can jump. The last rung can be 7 to 9 feet off the ground. And you can jump to the ground. This is a weighted ladder. Once you release it, it drops 2 to 3 feet per second, hits the ground and stays down. Otherwise, if you have ladders that keep going back up by themselves, does that make any sense? Or shall we have another story that includes a woman and a child? You know what I'm saying? Because a 150-pound woman can activate that and make it come down to the ground. But once she gets off of it, and the child that only weighs 50 pounds is on that same ladder, what happens? She gets a ride back up. How about your goosenecks up and over into the roof? This is what's going to hurt the firemen. If these aren't secured and verified, what happens to the firemen? Making the last leap up over the roof. They fall to their death. And this is modified ladders that are illegal. This is a swing out. And what happens is when you push this ladder, guess what it does? It does this big arc. And when it comes down and your dog is below it, what happens to the dog? Your child is below it, what happens to your child? The fireman is below it, talking to another fireman, what happens to his head? So if it can hurt or kill you, is it legal or illegal? This is what it looks when it gets down, with nobody below it. In order to get it down, you have to let it swing by itself. So does it fall smoothly? Or does it sort of arc and swing like a guillotine and come down and smash you on the skull? So modified ladders are illegal. Let's talk about some of the things you need to do. We talked about the permits. We talked about the sign off on things. So you need to not only have yourselves as somebody that's going to be signing off fire escapes and working and violating fire escapes, you need to work with also your fire department, your firemen. And we taught 400 firemen in the city of Elizabeth, so we do already have some video, a 1-hour video, and in a 4-day stretch, we brought them all in a room setting like this, and we just showed them how to spot fire escapes. First of all, just identify the address of where these things are throughout the city. So over the next 3 to 5 years, with 3,500 guys out there, you think you'll identify every fire escape? If that word gets back to you where every one of these addresses are, can you guys drop a tag on it, yellow or red, and start the process? So that your firemen know at least the fire escape has or has not been inspected, and that your firemen can make a judgment call right on the spot. So can the tenants who go out there for smokes and stuff. If they're walking out to smoke on a red or a yellow fire escape, think they're going to do that anymore? Think they're going to pay their rent anymore if they have a bad fire escape? So working with various ideas out there, you'll start bubbling this thing up to the top. Now, whenever we get a violation, what we're going to do is we're going to send you a letter that says, and this has all happened since the Chicago incident where that piece of steel hit somebody on the head. Everybody got involved in the lawsuit, including the city, because the city was accepting opinion tests. To the best of my information, knowledge, and belief, the fire escape is structurally sound and has been kept painted. That's an opinion test that comes on the structural letterhead of a structural engineer. And by the way, somewhere down below, guess what kind of disclaimer he says? Everything I didn't see, everything I didn't verify, everything that was unknown, I am not held responsible for. And this opinion is only today, because I can't tell you what this fire escape will do tomorrow. So what did we basically just do? He collected a check through the window, and if the thing breaks down 3 days later, what liability does he really have? So we send you a letter, and we send you the letter, Mr. Inspector, you wrote a violation. Do you want me to give you an opinion test, and I'm going to give you 2 pages worth of disclaimers, Or do you want a calculated load test, which is my level 2? See the calculated load test right there? So opinion 1, you're going to get a nice form, pass-fail, some pictures, and that's it, and we're done. I got a bunch of disclaimers. I'm going to send you guys this so that you guys can read what it is. A level 2 now says, no, you know what? I did this inspection. There's some unknown, so I will have to verify your wall. I will have to verify some of these welded connections. And some of these 50 to 75-year-old bolts, I will have to verify them, and I will have to load test them and or certify them. And obviously my level 3 is a load test. So, some numbers. I will give you a visual opinion for $500 with a lot of disclaimers. I'll give you a calculated load test for $1,500 because it's going to be oversight, and I got to watch a vendor repair it and make sure that, because he's not signing off. I have to sign off on what he did, so I need 3 to 5 visits, and that's not cheap. So most engineers are going to charge anywhere from $1,000 to $2,000 to oversee, because that's your eyeballs. He's the guy convincing you that this is getting done correctly. You don't have to go there and babysit this, because somebody's about to give you a calculated load test that says, I've verified all these repairs. And the vendor pulled the permit, because that's part of my sheet that I got to fill out in the beginning. Or, I want $5,000 to load test this fire escape, because that's a level 3. And in lieu of a load test, if I can convince the inspector in this room that we've done everything possible to refurbish this fire escape and we've eliminated every unknown, so a calculated load test has no disclaimers on it. The only disclaimer I can put on a calculated load test is about the steel, whether or not the steel is going to bend or not. Well, I can't do that because unless I load test it, that's the only unknown. So I have to put a disclaimer that says the only thing we don't know, but the steel doesn't show any rot, doesn't show any bending or anything, because only a load test will prove that whether the steel is. So how do we deal with the steel on these fire escapes that are 50 to 75 years old? Well, what we're teaching nationwide is that all fire escapes that are 50 to 75 years old should go through one load test in their life cycle. And then after it's been load tested, whether you do it immediately on all buildings that are 50 to 75 years old, you immediately load test those fire escapes as part of that confidence test, and then they don't have to be inspected for another 25 years, load tested. They still do their 5-year calculated load test or through an engineer every year, and then they do that annual load test with the owner. But after you load test your fire escape, you should not have to load test it for another 25 years. And on these older buildings, it's not just a fire escape load test anymore, it's a wall envelope study that has the fire escape on it. So every 25 years, this time around it's a fire escape load test, but 25 years from now it's an envelope study that includes the fire escape. You get it? But all along, he's got these 5-year rules. He's constantly painting it now, and it's under that watch, just the same way you watch elevators. Now, any building that's 25 to 50 years old, you might give it a 5-year, you might certify it now, but give the guy 5 years before you force him into a load test. Because the fire escape is much younger. Okay? So these are recommendations. They're not laws, but we recommend that fire escape, every building be at least load tested once in its lifetime, and after that load test, not for another 25 years. As long as it has routine 5-year maintenances on them, okay? This is what a load test looks like. You put the weight on top of it, or you pull the weight down below it. So we were load testing almost 3,000 pounds on this fire escape and using this 7,000 pound truck down below. And you use a load cell. And as you start cranking it, the load cell gives you the weight. Very time consuming. This is a 10-story building. So we're lifting the tail. So it's a cable that runs up all the 10 floors, and we load test one floor at a time. 30 minutes every floor. Sorry about the noise, but basically what you're doing is you're basically verifying that it can handle those 3,000 pounds. So I either bring 3,000 pounds to every floor and watch it for 30 minutes, or I keep the 3,000 pounds on the ground, run cables up, and pull it on every floor for 30 minutes. Whatever's faster and easier and cheaper to the client. Okay? Now what happens if my wall, though, looks like this on the inside and I didn't do any verification? What could happen to one of those floors? So before we load tested this fire escape, we have to drill. This is the actual fire escape. This is what we have to do. We have to drill holes and send that probe, you know, the one you get at Home Depot that you stick it through, it's about 3 feet long, it's got a little light on the end, you go there, and now they even come with a camera, you snap a shot. These are snapshots of inside the hole. Now, this is a wasted hole, because not only did I drill it next to the connection, I have to refill it when I'm done. Why didn't I just 3 to 5 inches away drill the same 3/4 hole, because this is not a 1 3/4 hole, I have to drill 2 or 3 of them to get that much space so I can get in there. But if I do it 3 to 5 inches away and I put a new epoxy bolt, do I care about what this hole looks like inside? So sometimes it's cheaper not to verify the connection, it's cheaper to verify, just to duplicate it and eliminate that unknown, which is only about 2 to 3% of the building. This is what it looks like inside. Firescape CSI. What the hell are we looking at? I don't know, but we got to look inside every one of these things. Very time consuming, very costly. This is what the plates look like inside of the same building. Some of them are broken and some of them are good. This whole verification process takes so much time, because can I load test it until I verify it? Because I know what a passing grade looks like. What's a failing grade look like? Got a fire escape on my head. Because where do you crank the machine? Away from the fire escape or below the fire escape? You understand? It's crazy. So there's some risk. So you saw the Tacoma test. Well, we have samples of the Houston test. I think in the past I was working with John Bush, and I sent him some samples of what a test would look like, so I'm going to send that again to you guys. The questions, the annual. This is a test typical out of Boston. All they want is that, to the best of my information, knowledge, and belief, the fire escape is in conformity with the building code. That's all I have to sign. Is there any room for error here? When I'm not asked to make a statement? To the best of my information, knowledge, and belief that day. You think you can sue me the following day? You asked me that day. Well, it fell a month later. Well, you didn't call me in a month later to see. I might have told you something different. And I wasn't watching your fire escape. Did any earthquakes occur? Did any trucks hit it? Did anybody do anything on the inside that compromised the outside connection? Right here, what we have is repair criteria. Every one of these talks about the ladder, the platforms, the supports, the ladders, the treads, the weight balance. And you know what the standard repair guideline is? If you have a connection with rust in it, remove 100% of the rust. Prime the connection on the inside, put it back together with a bolt. Seal the connection. That's the extent of your training for how to repair every fire escape in the United States. Apply that technique to anything that's called a connection. Don't weld it, because the EPA doesn't let you weld things that are older than 1978. But if you are going to weld a fire escape, and just so you know, you can weld fire escapes. I can put up a brand new welded fire escape for you tomorrow if you want. But the one thing that we're going to do is make sure we seal it with silicone. After we do all our welds and prior to painting it, or after we paint it, we're going to seal it with silicone. Because guess what's going to start getting eaten right away after I put it up in the air? Inside that connection. So I can't just rely on paint to seal that welded connection. I have to rely on silicone or something so that it doesn't let water and air get back in there, okay? So I'm not saying you can't weld fire escapes. I'm saying there's a lot of restrictions, a lot of problems with verifying the weld after the fact. So we'll give you the disclaimers. Now, this is all industry standards. This is what you want from now on. Every time somebody gives you a report, if a structural engineer is going to give you a report, in the confidence test it says, give me 2 things. Mr. Structural Engineer, you must give me, you must identify the fire escape violations to make it easy for the client to get the work done, or you must do a drawing of the fire escape and point on the drawing where every problem is. What do you think is faster and easier and cheaper for the client? Walking around with a $2 spray can, or drawing the beautiful fire escape in elevation, cross and plan? Right? So for a $2 can, the guy's going to spray, because who else wants to see these violations? Right? You want to see the violations because you want to go back there and check it out if you can. But now, photos must attach to the violations. So the report from the engineer must include photos. Because if he's going to say, well, we got a problem, what do you want to see? If he doesn't provide and he gives you this one page and he says words like, oh, there's deflection and deterioration. How does that help you and or the vendor fix this fire escape? If he didn't mark up the violations and he just wrote this little one-piece page and got $500 for it, does it help you? Does it help the client? Does it help the vendor? It helps nobody, because now you're relying on the vendor to go there and fix what he thinks the engineer wants done. Whereas when you hold the engineer accountable and he's got to give you a report. Now, this is a nice fancy report. We made it with some nice headers and stuff, but everybody here that's printed out pictures, can you print 9 per page, 4 per page? If they're doing family pictures, can you tell your PC to print 1 per page, or 4 per page, or 9 per page? So if an engineer who doesn't have this fancy report set up, can he give you 9 per page? Are those big enough photographs for you to get an idea of how bad the situation is? And if he took 76 photographs of violations on that building, do you want that attached to your report, to your confidence test? So that when he says it's bad, he says, look on page 2, there's falling treads. Do you need to go there to verify the treads? Was that picture enough for you to write a violation that says, we need the fire watch, or we need to vacate the building? If he doesn't submit with photos, then it's not a good report. Repair procedures, I told you. Remove the rust, prime it, bolt it, seal it. Do you need any further training? That applies to anything that's a connection. Okay? Signage. Should there be signage at every window that leads to a fire escape, or every door that leads to a fire escape? What we're going to do right now is we're going to take a 5-minute break, and I have 2 things that we're going to be doing after this. I'm going to start showing some video, from some past video of downtown Houston. And because our plan was to take everybody down here, but it's going to be a parking issue. And so what we're going to do is we're going to show 5 or 10 videos. From here, I'm going to show you a couple of other videos that are from, for example, the greatest one, which was all that vendors and all those guys out in Portland. So that downtown walk around we just recorded, it's already up online. And then at the end of this, when I go down to downtown, I'd like to take 1, 2, or 3 of you guys with me, those that can go with me, because we want to record and have a one-on-one with you as we start looking at fire escapes. We're going to look at 5 or 10 in an area. You're the one that's going to be inspecting them, but we're going to be recording, so it's going to be dialogue back and forth. That training video of 1 to 3 guys of you that will go with me, so the rest of you can go on, I'm going to get back to you and put it on the Fire Escape Academy, so you can train indefinitely into the future. So as you move along and you no longer hold your position, the knowledge that we're passing here, which is getting recorded, you'll have, so that you can constantly train future people at your weekly meetings. You know how you meet on every 2nd Wednesday of the month or something like that? You guys can just watch these videos. So I'm going to show you some of these videos, but again, a majority of them will be from here, but a few of them will be from around the country, and then I'll show you some typical inspection videos on where technology has brought it. That includes a summary repair video and a slideshow of the violations. So let's take a 5-minute break, and we'll be back to